So today we're going to be graphing tangent and cotangent. Of the 6 functions, these are actually my favorite to graph. They are quite unique, and because of that, there are quite a few differences between these 2 and the other 4. Let's take a look at the tangent graph first. I'm going to draw my usual little diagram, just demonstrating what the curve looks like. This time, and only for tangent, I'm going to do a typical XY axis where the origin's at the center of the drawing. Starting at the origin per usual. For this curve, we're going to go out 2 to the left and the right. Still making 4 additional notches besides the starting point. The tangent curve is going to be in the middle of the graph, and then on the left and the right sides are actually going to be asymptotes. Sketching the actual curve. So the starting point is always on the midline. From here, for now I'll use max and min because those are the terms that you're used to, but technically that's not quite correct. Going to the right, we're going to go up to our max. And going to the left, we're going to go down to our min. Here's what this curve looks like. You're going to go up to that point, and then you're going to keep going. On the left side, you'll go down to meet that point, and then you'll keep going. This is considered one full curve of the tangent graph. Which is also known as the period. And I'll say this again later, but the easiest way to identify the period of a tangent or a cotangent is it goes from asymptote to asymptote. Now that you've seen the curve, let's talk about a few important details here. First, the shape of the curve. This particular shape, we call it the disco right. And we are kind of referencing the dance move here. It's popularized during the 80s. I believe the 80s. Where the arms go like that. I'll often abbreviate this as DR when I'm making my graphs. And the starting point starts at the center of the curve, as you can see in our picture there, which will be the midline. So for one full curve, again, we'll have two asymptotes. We'll have a point at the quote-unquote min, point at the max, and then a point at the midline. That's it. That's one full curve. Let's take a look at cotangent. They are very similar, and therefore can be easy to mix up at times. Cotangent. For this little drawing, we're going to draw it like the others where I kind of have the y-axis on the left side of the graph. And we'll go out our 4 intervals per usual, starting at the origin. Just like the tangent, there's going to be a lot of similarities here. The kind of outline is going to be the same, how you're going to have an asymptote on the far left and the far right. So that means when we start, we're actually starting with the asymptote and not at the center of the curve. In the middle, we still have the midline point. That's the same. And then we'll have 1 point at the max and 1 point at the min. The only big difference between the two graphs, besides the starting point being different, is the way the curve moves. Tangent is disco right, cotangent is disco left. So going to the left, we go up to the maximum. And to the right, we go down to the minimum. And the curve goes the opposite direction of tangent, yes.
Where do you get those maximum and minimum numbers from?
That's from your amplitude value, your A. That's what's going to give us. It's just like that. But
What's the name of it?
you're already ahead of me. We're going to call that the stretch. I'll get to that note in a moment. But yeah, amplitude doesn't quite fit anymore, but it has the same purpose. You're welcome. Thank you. So this is one completed curve. Again, they look very similar, just a couple main differences. So like I mentioned, the shape is different. This one we refer to as disco left. So again, I'll make my little doodle here. And the starting point is different. Starts at the asymptote. So there's the basic outline of both graphs, what they're going to look like when we do a problem in a moment. Now there are two different rules that make them on top of their curves. The graphing process is a little bit different from sine, cosine, cosecant, and secant. These are the two big ones. Now the first rule is what Devin just asked me about a moment ago. The A that you usually refer to as amplitude, it's going to serve the exact same purpose as it does in the other graphs, but we're going to call it a different name, and that name is stretch. On the test it will say amplitude / stretch, so we're basically giving it away. That's what that is, but formally it's stretch. The second one, and this is going to be a big one that you're just going to have to remember, the period formula is slightly different. For the other four functions, it's 2 pi over b. For tangent and cotangent, it is simply pi over b. Aside from those two differences, the graphing process is exactly the same. Let's take a look at an example of one of these. First example, y equals 2 tangent of x minus 1. We'll make our list. Reminder, number 1 is no longer amplitude, it is stretch. And then, per usual, we have the period, the interval, the phase shift, the vertical shift, and the domain and range. Domain, leave yourself a little bit of space just like we did yesterday. First off, let's start with all the general information. General equation, y equals a tangent bx plus c in parentheses plus d at the end. For this one, I do like to draw the mini graph for reference. Again, there's just a lot of detail we have to think about here. Tangent is where we start in the center of the graph, so I'm going to draw a centered graph here. Starting at the origin, 2 intervals, left and right. On the outsides, we have our asymptotes. They basically block off the curve. Asymptote on either side, 3 points in the middle there. And the middle point is always on the midline. And then from here, since it's tangent, this is disco right. So we're going to go up to the right and down to the left, creating our disco curve. And there you have it. Let's fill out the info. Stretch, you find it just like amplitude, it's absolute value of A. In this case, A is just 2. Period, remember the rule changes, it's pi over B. Pi over our B here is 1. So it's just a nice pi. Interval didn't change, period over 4. Our period is pi. So it's pi over 4. Phase shift, same as usual. You take the parentheses equal to 0, so x equals 0. Or you can write none. Vertical shift, still the d value at the end, -1. Domain will be determined after we make our graph. Range. On this graph, and we can even look at my mini drawing and get this information. From the bottom to the top, the y-axis is completely undisturbed, unbroken. All values are included in here. This range is negative to positive infinity. Let's make the actual graph. Again, on these especially, you will want to make sure you leave yourself space left and right because you never know where you need to go with the graph until you start putting stuff on it. And that's actually going to happen in example 2 for today's notes. Per usual, we'll go 4 left and 4 right. Leave some space on that x-axis. Intervals, our intervals are pi over 4 each. Again, I'll do the unreduced fractions at the bottom first. We have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And simplifying, we have pi over 4, pi over 2, 3 pi over 4, and pi. Repeat for the negatives. Let's figure out where we need to start. Looking at our shifts, we have no phase shift. We have a vertical shift of -1. So we'll put our starting point at -1. And I'm going to exaggerate this space a little bit just so I don't run into those numbers too much. So this is going to be down 1. From here, we'll start our graph. So again, the starting point is the center of the curve. So we'll start there. Now, I personally like to draw the asymptotes in first, just so we don't cross them. That's just a me thing. So again, if we're at the center of our graph, we need to go 2 left and right to reach those asymptotes. So if I go over 2 to the left, this is an asymptote. And then 2 to the right, that's an asymptote. And again, between the asymptotes, you should have 3 total intervals, 1 for each point, 3 points total. From here, this is disco right. We're going to go up to the right and down to the left. I always like to go up first and then down. And that's based on our stretch. Our stretch here is 2. So over to the right, we're going up 2. This is going to be my stretch up. Yes.
How did you know put the asymptotes at 5 or 2?
How did I know what?
You put the asymptotes at 5 or 2, so it's just 5.
It's just familiarity with the curve, but the I'm starting here at -1 in rough, like comparing this figure to my actual graph. I'm starting down here, and then 2 intervals to the right is the asymptote, and then 2 intervals to the left is the other asymptote.
So it's always 2?
Yes, you'll have 2 asymptotes, 1 on each side, and then in the middle there should be 3 intervals for your 3 points.
No, so my question was like, every time you start, you always have to go out 2 intervals?
Yes.
And put it,
Yes. And then we're going to go down 2 on the left side to get our arm going downward. So about right there. So again, I've got my asymptotes, my 3 points in the middle. And we'll draw on the curve. Questions on sketching the first curve, because I'm not done. Again, this just takes familiarity and practice, but once you get used to it, I actually find these are easier to graph. Now, reminder, the rule of thumb is you graph 2 periods. And reminder, I mentioned earlier, we know we have a period when it goes from one asymptote to the next asymptote. This right here that we have graphed is 1 full period. So we need to graph another asymptote to asymptote, and then we have 2. Once you have the first curve, getting another curve is extremely easy because this graph literally copies and pastes itself to the left and the right. So either way, we're going to have to extend the graph to make this happen. I think most of us naturally would want to keep going to the right, so that's what I'm going to do. Now here's the thing, and I'm going to be strict on this when I grade this, when you take this test. If you have to extend your graph to get more points, you must find these numbers. Don't just put blank tick marks. which I don't think is asking too much. And again, this is why I like to write the fractions at the bottom, so when I have to go back and think about this again, it's not hard because I already have my train of thought down here. So I'm going to keep going. 5 pi over 4, 6 pi over 4. Reducing up top, that's still going to be 5 pi over 4. 6 over 4, that's 3 over 2, 3 pi over 2. Graphing my next curve. This asymptote on the right here is now my asymptote on the left of the next curve. It's going to kind of double dip here. That's fine. And then again, you literally follow that pattern to the right. Copy, paste. So I have my asymptote. The next point after that is the minimum point here, which unfortunately is going to run into my fractions at the bottom, but that's okay. So here's my next point. Next interval is that midline point here. Next interval, I go up to that quote-unquote maximum, but the stretch up. And then my next interval is the next asymptote. And then sketch your curve. And I completely forgot that I didn't draw on my midline like I usually do. So my apologies there. Since there's less points on this graph, it's a little easier to keep track of without a midline, but it still helps visually. So like I said, it literally just copies and pastes itself. It goes in the exact same pattern, left and right, whichever way you go. This is 2 full periods, a completed graph. So I can stop here. Questions on sketching the curves before I do the domain? Okay. Just like with secant, cosecant, the domain follows the same pattern where it picks up and stops at each asymptote. So it's just asymptote to asymptote, asymptote to asymptote. And we only have 2 intervals here, so that's what we're going to have. I'm going to write out that pattern real quick, just like I did yesterday, and then I'll fill in the actual numbers below. Asymptote to asymptote, we'll have a union, and another interval, and then it would just keep going. So for our first set of asymptotes, we go from negative pi over 2 to positive pi over 2. These are going to be my values. Union and my next set of asymptotes. The next set goes from pi over 2 to positive 3 pi over 2. That's all I have graphed, so that's all I have to write down, but of course there would be more after that. Questions after seeing a completed problem? One more example, and a cotangent example. Example 2, y equals 3 cotangent 2, then the parentheses, x minus pi over 2. We'll make our list. First off, we have stretch, not amplitude. Then the period. Then the interval. Then the phase shift, vertical shift, domain and range. General information first. We'll start with the general equation. We do mix it up a bit this unit, and we do throw the other equation form that you use to write equations from graphs and descriptions that you did in the last unit. That's what you're looking at here. You should recognize it because the b is outside the parentheses. So this is A, cotangent, B. So that means in parentheses we don't have bx plus c, it's the x minus phase shift, plus the vertical shift at the end. So for solving purposes, you just need to know that the b is now outside the parentheses. That's about it. Mini drawing first. Cotangent this time. We'll go 4 intervals to the right. Starting at the origin, we have an asymptote. That's where we start, not in the center of the graph this time. 3 points after that, and then the next asymptote. Again, 3 points. The second point, the middle point, always goes on the midline. This time we're doing cotangent, which means it has a disco left shape. So this time, I'm going to go up to the left, down to the right. And again, that is dependent upon my stretch. Let's fill out the info. Stretch again is A, which is 3. Period, reminder, pi over b, not 2 pi over b. So it's pi over my b value this time is 2. So my period's pi over 2. Interval, period over 4. Pi over 2 divided by 4. We've talked about this before, so I'm not going to go over mathematically how this works out, but you'll get pi over 8. Again, the trick here is you can just multiply the denominators if you have a fraction over a number. Phase shift, per usual, set the parentheses equal to 0 and solve. If I set this equal to 0, it's just going to change the sign on the pi over 2. So I'm going to end up with x equals positive pi over 2. Positive is just for emphasis. You do not have to write it. Vertical shift at the end, there is nothing there, so this is 0 or none. Domain will be determined later. Range, negative to positive infinity. Questions on the information? Now the graph, again, give yourself some space left and right just in case. Four intervals left and right. This time my interval value is pi over 8. Working with the fractions at the bottom, we have 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. Reducing. Pi over 8, pi over 4, 3 pi over 8, pi over 2. Repeat for the negatives. Let's figure out our starting position. We have a phase shift at positive pi over 2, but no vertical shift. So we're going right pi over 2, which is all the way at the end of our interval. Starting here. phase shift at positive pi over 2. We start at an asymptote for the cotangent graph. So I'm going to line over this in my red to show that it's also an asymptote along with the phase shift. So let's talk about this. If we were to follow exactly what I have drawn up here, as in this asymptote here is the one on the left of my drawing, I would need to go out 4 more intervals to the right to fit in a curve. Clearly that's not going to happen. So while that is probably what feels like the easier thing to do, I don't have the space for it. And a lot of you may not either. That's not a big deal. Instead, we can let this asymptote just represent the one on the right, and we can essentially go backwards. Because reminder, if I drew it to the right, to the right, to get the left side, I would just essentially like copy and paste. It'd be the same thing. So going backwards, when you're starting with the asymptote, is the same as going forwards. So I'm going to identify my left asymptote on this graph. Again, you have 3 points in between asymptotes for the curve. So 1, 2, 3, the next interval over is your next asymptote. On 0, reminder, 0 is an interval, don't skip it. Two asymptotes, 3 points in between, 3 points for the curve. The middle point is always on the midline. It's the center of the curve. From here, this is a disco left shape, so we go up to the left, down to the right, so I always like to go up first. That's determined by our stretch, which in this problem is 3. So I'll be going up 3, and when I do the bottom arm, down 3 on the y-axis here. So up and left, I'm going to go up 3 to the left, and down 3 to the right. And then draw in the arms. There's my first curve. Once again, this is a full period. I need to copy this shape. And again, I'm going to keep moving to the left as we discussed. I don't have room on the right. So we're going to do that all over again. We have an asymptote on the right side of our graph now. The other asymptote, we have 3 points in the middle. It's going to be our last interval here on the end. This will give us our other asymptote. Once again, each pair of asymptotes need to have 3 intervals in between to represent those 3 curve points. The middle point is the center of the graph. Point on the left, again, you can just copy and paste it at this point. Point on the left goes up, point on the right goes down, and then you sketch your curve. Once you find your first curve, finding more curves is very easy. The curves should look identical. If you graph 2 curves and they don't look the same, a mistake has been made. This is 2 periods, so I'm good on the graph. I just need to fill in the domain. Again, the domain is asymptote to asymptote. And when we have 2 periods, we just have 2 intervals. First pair of asymptotes, we have negative pi over 2 to 0. Second pair of asymptotes, we have 0 to pi over 2. And I can stop there because that's all I have graphed, so that's all I have to write down.